Page 323, question number 9. We have two graphs to explain. So let's take a look at our first graph. In the first graph, our mechanical energy is going up. Our potential energy, I'm going to call it gravitational potential energy for the sake of argument, and our kinetic energy stays the same. So if our mechanical energy of the system goes up, that tells us a force is doing work to add energy. So the mechanical energy of our system is increasing. Now our kinetic energy is staying the same, which means V does not change. So it's going the same speed. It does not change. It's going the same speed the entire time. It's not speeding up and it's not slowing down, but our potential energy, so our gravitational potential energy is changing, so our height has to be increasing. So if you want, you can think of this as an elevator. The motor of the elevator is doing work to add mechanical energy to the system, and that is showing up as an increase in gravitational potential energy because the height is increasing. The kinetic energy is staying the same. It's not speeding up, it's not slowing down, it's going uphill at the same rate. So an elevator would be an example of this type of a graph. Now for graph B, when we take a look at this, we can see that our mechanical energy again is going up. Our kinetic energy has gone up and our potential energy is going down. So because our mechanical energy is going up, again, we have a force doing work. It is adding energy into the system. In this case, our gravitational potential energy is going down, so our height is decreasing. And our kinetic energy is going up, so V is increasing. Now our gravitational potential energy went down, but our kinetic energy went up more. So I'm going to put a second arrow to indicate it went up more than our gravitational potential energy went down. That means that our kinetic energy is increasing more than gravitational, so something has to be doing work to speed it up as it's going down the hill. So my example for that will be pushing a toboggan. So as a little kid, when I went tobogganing downhill, you put your hands on the ground and push as much as you could to increase your speed as well. So, or you could have somebody pushing you, something along those lines. But we have to have that force causing their mechanical energy to go up as they're going down the hill and going faster and faster.